So this is section still a part of 6.3, but instead of long division, this is known as synthetic division. So we want to make sure that we have a basic understanding of long division before applying our concepts for synthetic division. So we also want to discuss the remainder theorem. The remainder theorem states if a polynomial p of x of degree where n is greater than or equal to 1 is divided by x minus a, where a is a constant, then the remainder is p of a, which sounds like a whole lot, but it is really actually quite simple when we start putting it into play. It's talking about that you have a polynomial that's a degree higher than 1, or 1 or higher. So anything linear, or quadratic, or cubic, or quartic, or quintic, or anything of 6th, 7th, 8th degree from there on, is divided by x minus a. So you have to divide by a linear factor. So this is known as a linear factor where x has a degree of 1, where a is a constant. So x minus 2, x minus 5, x plus 8. Well, then the remainder is p of a. So you're taking that value for your constant and substituting it into your polynomial equation. Synthetic division is a simplified process of long division only when working with linear factors. So again, this is only available to you to use with linear factors. You can't have where you're dividing by a quadratic or dividing by a cubic. You can only divide by x minus a or x plus a, which are examples of linear factors. For VIX, we have that this is going to be the setup of how you divide. So it's a little different than what we saw in long division, where we have the kind of fraction bar that goes that way, or your divisor bar that goes that way, where you have this little box, and inside that box is going to be your coefficient, or excuse me, your constant. Across the top here are going to be a list of the coefficients of your original polynomial, and what you get as a result is going to be your quotient coefficients. If a divisor is x minus a, we want to put the constant in the box. So for example, if you're dividing by x minus 2, 2 goes in the box. If it's x plus 4, negative 4 goes in the box. So think about it in terms of zeros. What would the zero be? And that's the value that is your constant. So your quotient is depressed by 1 degree. So after we solve, once we get our final answer as our quotient coefficients, if this original statement was a cubic, it's now being depressed by 1 degree, so our result is a quadratic. So our steps are bring down, multiply, add, repeat 2 and 3 until done, and we'll see what that means. So for example 1, use synthetic division to simplify the polynomial. So if this is my polynomial, 4x cubed minus 3x squared minus 7x minus 8 is divided by x minus 1. So this is my dividend, this is my divisor, but because it has a degree of 1, we're able to use synthetic division. So in the box would go your constant, which is in this case 1. Again, it's kind of like the opposite of what you would think of, or if you think of your 0. So the coefficients of your polynomial get placed along this top line, 4, negative 3, 7, negative 8. From here you start at the beginning. You always bring down the first. So sorry, we realize that this should be a positive 7. So again, your coefficients are 4, negative 3, 7, and negative 8. So to start over, you bring down the 4, you multiply, 4 times 1 is 4, that number goes here. Then we add. Negative 3 plus 4 is a positive 1. You multiply again, 1 times 1 is 1, so that goes here. You add again to get 8. 8 times 1 is 8. You add again, and you get 0. So there's a couple of things this means. One is that, yes, x minus 1 is a factor because there is a 0 as a remainder. So your answer is 4x squared plus x plus 8. 4x squared, because this was x cubed, it depresses by 1, plus 1x plus 8. And we don't have to add on 0 divided by my initial divisor because it's already part of it. But if it says to simplify the polynomial, you also want to note that in its simplified version, f of x is equal to the divisor, which is x minus 1, times your quotient with their coefficients. If you were to distribute this back out, you should end up back to where you started. And that's the whole point of using synthetic division to simplify the polynomial, because eventually you might be able to factor that as well. We also have to use synthetic division and the remainder theorem to find p of a. So synthetic division, if our polynomial is x cubed plus 4x squared minus 8x minus 6 divided by x plus 2, negative 2 goes in your box. Your coefficients get lined up on the top. You bring down the 1, multiply. That gives you negative 2. We add. 4 minus 2 is 2. Again, multiply. Negative 4, add, to get negative 12, multiply to get positive 24, and add to get 18. So we have a remainder of 18. For here, if we're looking to find the remainder, to find P of A, it's P of negative 2, because my A value is negative 2. And all you have to do is substitute in that constant. So if I substitute in negative 2 for x's, which is what I've done here, and I put that in a calculator, I come up with a result of 18. These two should check out.